Alright, so here's some help with worksheet C on the truss problem. And a truss is, the sides of a bridge. So the sum of the moments. Now, if you forgot what moments are twisting forces or torques. And then calculate all the reaction forces. So see these three red lines? Those are reaction forces. They have a little slash through them. It's kind of engineering notation. Basically, you have two forces going down. Imagine two different pterodactyls are perching on top of this bridge and putting some serious force down. I don't know how much a pterodactyl weighs, but let's pretend it's 200 pounds and 300 pounds. And then on this pin, part of our bridge, the thing that pins it to the ground, it has two forces, a sideways force and an up force. And on this pin, it has an up force. So, to do this problem, and if you didn't get this before, it's totally understandable because I usually do this before, and I don't know. I usually do this in class together, so sorry about that. But what's important when you do a moments kind of problem, and whenever you start a bridge problem, is you pick a point to be your fixed point. Okay? Oops. Can I undo? There it is. Okay, that point is going to be my fixed point right here. Fixed point is A. And that's important because when you're doing twisting forces, you have to know what they're twisting around. So this guy's my fixed point. If I called that my fixed point and I looked at this bridge, then if you imagine this is like a wrench and you put your finger down on the green thing, if there's a 200-pound force pushing down here, that would try to twist my bridge down this way, right? This force would try to twist my bridge down this way if that was a fixed point. Think of it like a wrench. This is a wrench and you applied a force here, it would try to twist that wrench this way. The only thing fighting those two down magenta forces is this one green force that I'm about to draw right here where it pins in, pushing up. Oh, I guess it's not green, it's also magenta. Okay, so these two down forces are fought only by this one up force. Okay, so how do we do that? Well, we write a formula, and if you've forgotten, moments are calculated by the torque, or the moment, equals the force times distance perpendicular. Okay, so if I do it for this problem, I'll turn it black here, text box. Okay, for this problem, my 200-pound force times its distance from the fixed point. Here's the important part, because some people would put 3 and you'd be wrong. The distance perpendicular is 2 feet. See how the force is going down? Well, you want to pick the across distance. So 2 feet plus my other twisting force that's trying to turn this bridge down into the ground this way would be a 300-pound force times its distance away. Now, how far is it away? 4 feet. Okay. And those two down forces are only canceled out by this one up force. Now, why do they have to be equal? Well, guess what? If these forces weren't equal, the twisting down and the twisting up, then your bridge would be actually rotating into the ground or rotating up into the air. And bridges don't do that. So these two, the twisting forces have to equal out, and it's going to equal, you know how I had 200 pounds here and 300 pounds here? Well, I don't know how many pounds are here, so we're going to label this. It's on point B, so it's a reaction force. Oops. Yoink. It's a reaction force on point B in the y direction. times its distance away. How far is this guy away from your pivot point? 2, 4, 6. It's 6 feet away. So you're going to have 200 pounds times 2 feet, 300 pounds times 4 feet equals reaction force on B in the y direction times 6 feet. So I'm going to multiply these together. Let's see, 200 times 2 is 400 foot-pounds plus, and then this one's going to be 1200 foot-pounds, and it equals RF BY, reaction force of B in the y direction, times 6 feet still. And then that would equal, what, 1600 foot-pounds equals RF reaction force of joint B in the y direction. RFBY. And then, did I not do that? There we go. Times 6 feet. So I have one more deal. Divide both sides by 6 feet. And what's 1600 divided by 6? It's going to be 266 and 2/3. And I take the feet off because I just divided by feet, right? So 266.67 pounds of force equals RF reaction force on joint B in the y direction. So I just found out one of these. Okay, maybe I can take it over there. I wonder if I can copy this. Copy, paste, oops, undo, guess not. Okay, so this is going to be, sorry about, oh no. What did I just do? Whew. Oh, no. Am I not on text anymore? There we go. 266.67 pounds force. Alright. There we go. Now, what's cool is I can figure out the two forces on joint A now, because another cool thing, you know how like your twisting forces down have to equal your twisting forces up? Well, guess what else? All your up forces have to equal all your down forces. So, see how I have two red arrows pushing up? And now I know this guy is actually a 266.67 force. Then I have to have two up forces to cancel out these two down forces. So you can write that. You can be like, okay, here's my, this guy up here was the twisting forces. Okay, now we're going to do the sum of the y forces. Okay, down here. So the sum of the y forces is going to say all my ups have to equal all my downs. So I'm going to say 200 plus 300 must equal this 266.67 plus, now how am I going to name this guy? It's a reaction force on joint A in the y direction. So all I got to do is subtract 266.67 from 500. I could do that in my head, but I'm on some pain meds, so maybe I shouldn't. 500 minus 266.67. Boom, 233.33. So RFY, 233.33 pounds. I could have known that, but reaction force on joint A in the y direction. Okay. There it is. 233.33 pounds. Okay, and our last one is the easiest one of all, so we saved it to last. The sum of the x forces must equal out. Here my twisting down had to equal my twisting up. Here my forces down had to equal my forces up. Well, guess what? With x's, my forces right have to equal my forces left. Now look on this picture. I see up and down and right. Do you see any left anywhere? No. So, if there's no other forces, then my right force, also known as reaction force of joint A in the x direction, has to equal all the other left forces, which are 0. That happens a lot of times. Oftentimes your answer to the x part is 0. Anyway, so that's how you do the truss problem. We're going to do a ton more of these in the future. Hopefully that makes a little bit of sense. If not, when you do it again with me in class when we come back in the new year, we're going to do a ton of them until it becomes more comfortable. I did want to take a quick look at this. I did this ahead of time. This one, I wanted to show you. If you had two forces like this, I called this vector A and this vector B. I turned vector A into its y components by doing vector B, 27 sine of 30. And then I turned vector A into its y part by doing 43 sine of 70. If you're wondering where I got the 70 from, I always use my angle from the x-axis. And then I did the same thing for the x parts. And do you know that you can find the total x by adding up the two individual x parts from my two component vectors? So I turned this into x with cosine, I turned this into x with cosine, and I added them up to get 38.9. On my y's, I did the same thing. I turned this into its y part by doing 27 sine of 30. Check out the negative sign though. Why did I put a negative on there? Because it's a force down. And if it's a force down, then you have to make it negative. If it would have been, up, I would have left it positive. And then I turned this guy into its y part by doing 43 sine of 70. And I added those two numbers up. And then remember from the other day, if you have your total y and your total x, you can find magnitude by typing in its Pythagorean theorem, a squared plus b squared equals c squared. And the magnitude of this guy is a 46.64 Newton force. And its direction you find by doing inverse tangent of y over x. And I don't think I did that yet. Do we have inverse tangent on here? Man, no. Let's see. How about inverse tangent calculator? Can we do that? There we go. I want arc tangent of 26.91 over 38.09. And we can find out the angle. 26.91 divided by 38.09 equals what? Oh man. Not a number. Oh shoot. It's a bad online calculator.